Hello. Hello.
Yes, Martin, now I can hear you. Okay. So, Martin, there is some issue with the pictures you have sent me on WhatsApp, right? Homework.
Are there any issues? Like, I don't think.
You have sent me the homework, right?
Yeah.
Okay. Yeah, so Martin, there is something wrong you have written. I mean, the way you have written is actually wrong. Let me tell you.
Okay.
Come to this question number 2, second part. Although the picture is not complete, but anyway, come to third part. Say you are writing it like this. See, that's the question, Martin, that PQ is, 1.28 centimeters, right?
Yeah.
PR is 2.56 centimeter. And then you have your PE 0.18 centimeter and RF is equal to 0.36 centimeter, right? I mean,
Yeah.
that's the triangle
Yeah. Correct.
P, Q, and R, and then you have a line EF somewhere. So in the question, basically you have to check that EF is parallel to QR, right?
Yeah.
So it will be parallel only if the ratios are going to be equal, right?
Yeah.
Okay. Now you have written it like this, Martin, that initially you are writing that PE upon EQ is equal to PF upon FR, right? And then you are putting the value. But you don't
Okay.
know whether they will come out to be equal or not. So you cannot put this equal sign right here. We don't know they are equal or not, right? We are going to check whether they are equal or
Yeah.
not equal, right?
Okay.
So you will separately calculate. So don't write like this. Simply calculate, first of all, what is PE by EQ. So after putting all the values, you are getting something 0.18 divided by 1.10. Clear?
Okay.
And also you cannot leave your calculation like this. Please simplify this thing. Okay.
Okay,
So
ma'am.
remove the decimal. So you will get like
You
18
like
divided.
multiply it into 10?
If you remove this decimal, so this is after two places, right? 1, 2. So you are going to place two
Okay.
zeros. Similarly, you have in the denominator, one place, two place. So after two places, you are having decimal. So 1, 1, 0, and then it will be divided by 100. That's how, right?
Yeah.
Yes. Now this 100 will get cancelled out. So you can
Sure.
use the table of 2 because both are even. So 2 into 9 and 2 into 5, 10, and then again 10, so 55. So you are getting 9 by 55. So always reduce to the simplest form. Any fraction, you should reduce it to the simplest form. Now it cannot be divided any further, right?
Yeah.
Okay. So here you cannot stop your calculation. Then separately calculate what is PF upon FR. So it is like ultimately you are getting 0.18 divided by 1.10 after doing all the calculations, right? I mean, put the value first. So again, you are going to get 9 by 55. Clear?
Okay.
So now you are seeing, observing that they are equal. So now you can write that PE upon EQ is equal to PF upon FR because we have already checked. So here we can put this equal to sign. Getting the point?
Okay.
Okay. And in the end also you are writing it's equal. So EF is parallel to QR. Why? There's no mention of theorem.
Converse.
Exactly. You will lose marks. Mention by which theorem this it is parallel. So by converse of Thales theorem or basic proportionality theorem, and always write complete. Sometimes I write in short BPT. You will write complete by converse of basic proportionality theorem.
Okay,
EF
ma'am.
is parallel to what QR, right? So the way of writing is wrong. And also like you have not complete the calculation. So reach up till here 9 by 55. And in the same fashion, you will write part 2 also, right?
Yeah.
Okay.
I'll fix this, ma'am.
Yeah, correct this one also and second part also. So don't put equal to sign in the starting because you don't know whether it will come out to be equal or not.
Okay.
Okay. Now come to the 10th question, Martin.
Okay, ma'am.
6.2 10th question. Just let me open the book. Yeah. So actually, it's from your picture. I'm not able to understand properly. Let me just see what you have done. Okay, question number 10. Now open your copy where you have written. So it is given, right? That, okay, let me draw a trapezium first of all. So diagonals of a quadrilateral ABCD. Okay, you have to show that it is a trapezium. So you are taking it like this, AB, yeah, CD, okay. And then O, and you have done a construction, which is EF, okay. Okay, so Martin, first of all, you have simply written, always write given. Use these words, okay? Given and to show,
Okay.
and then your proof. Please write this properly, because in geometry, it is always good to write everything. See? So given, what is given? Okay, you have mentioned that AO upon BO is equal to CO upon DO. Okay, all right. Now, what you have to show that ABCD is a trapezium. So you have to write like this, ABCD is a trapezium. You have to show it. Clear? Okay. So, okay, before proof, you are doing some construction here. So what is the construction?
You draw like a separate line by separate line drawn by.
Okay. Okay. According to you, I'm just checking. Okay. You have done EF parallel to AB parallel to CD. So this way you have drawn it. Okay. So in triangle DAB, you are taking. So I'm writing according to you. Okay. Let us check if this is correct or not. In triangle DAB, okay, DAB. So you are writing DE upon EA. Okay, there's no mention of theorem here in your copy.
I wrote in brackets B dot P
Oh,
dot.
yes. Okay, okay, fine, fine. I didn't see. So DE upon EA is equal to what you have written, DO upon OB.
B open O.
Okay, fine. This is BPT. Okay, all right. Next is okay, which page is next? Actually, okay. So next step, it's not very clearly visible. What you have written, can you tell me?
AO by OB equal to CO by DO.
Yeah, from where you are writing it? It
The
is
given,
given.
the given.
AO upon OB is equal to CO upon DO. Okay, that's given. Okay, fine. So what you have concluded from here?
Yeah, bacteria cross multiplication.
Cross multiplication. So you want to get like DO upon OB.
Yeah.
You are getting AO into DO is equal to CO into OB. Okay, that's right. So you are basically getting
AO by CO equal to DO by OB.
AO upon CO is equal to AO upon CO. Oh, say mistake here, Martin. There's one mistake. Now look here. You are doing AO upon CO. Clear? So you are bringing this CO here. Clear?
Okay.
And then you are writing is equal to DO by OB. Is this correct? DO is actually on the left hand side of the equation. So you cannot simply write it on the right hand side. Yes?
Yeah.
So no, it's wrong. This step is wrong. This DO will actually come here. OB divided by DO. Please correct it.
Okay.
Right?
Sure.
Okay. Now you will do one thing here, because you want DO by OB. Look here, this is DO by OB here, right? So you can flip this whole equation. So you can write CO upon EO is equal to DO upon OB, just to make the right
Oh,
hand side same, right?
okay. Yeah.
So this will be your second equation. So now from first and second, you can write that DE upon EA is equal to CO upon AO. Okay. Now you have taken triangle AOC. Now where is triangle AOC? AOC. Is there a triangle
That's
AOC?
ADC, ma'am, actually.
Okay, ADC you are taking. Okay. So in ADC, you are getting DE upon EA is equal to CO upon AO. You have done mistakes, so please correct your right hand side. It's actually the reverse, right? This is correct, okay?
So OC by AO.
OC, yes. So see in the figure also, you are taking this triangle, right?
Yeah.
So, I mean, this side will be upon this side, right? Like the half one actually. So this upon this. Okay, anyway, just look in the figure. So this is the correct. Getting the point?
Yeah.
Okay, so in triangle AOC, you're getting this thing. So that means, okay, where's the next figure? Okay, by converse of BPT, you are writing. So according to you, okay, by converse, so I'm getting DE parallel to DC. Okay, fine. So from here, what you are concluding?
OE, ma'am. It's OE, ma'am.
Wait,
OE parallel to DC.
EO parallel to DC. Yes, okay, sorry. OE. So Martin, your O and D are quite similar. So please, I think in your copy also you can write it. Okay. Sometimes I'm getting confused between your D and O sometimes. So please correct it.
Okay, ma'am.
Okay. OE is parallel to DC. Fine. And by construction, you have done, Martin, what you have done by construction? EF is parallel to AB is parallel to CD. EF is parallel to AB is parallel to CD. Okay. So what you are concluding from here?
That DC is parallel to AP.
Okay. CD
From
both here.
both three, took equation 3 and 4.
So, okay. So this is 3 and this is 4. So now you are writing DC parallel to AB. DC parallel to AB.
Yeah.
But Martin, this you have already taken this in your construction. Actually, your construction was wrong, Martin. This was actually you were supposed to prove and you have taken it in the construction itself. So what's the point of doing all the proof? Isn't it?
Yeah, ma'am.
So here's the mistake. Getting the point? So ultimately, you are proving something which you have already taken to be parallel, isn't it?
Yeah, ma'am.
Yeah. So your question is actually wrong. You have to do it again. So please do it with me now. Okay.
Okay.
So let me just show you where is your mistake. Okay. The figure will remain same. You can take like any figure. You can take it like this also. Any quadrilateral. Although, sorry, draw it properly. So it's something trapezium. So I'm taking it like ABCD like this. Clear? This is
Okay.
O. Okay. So actually you have to show that AB is parallel to CD. So first of all, written what is given, please write. And then to prove that ABCD is a trapezium. Right?
Yeah.
Okay. So this means, I mean, that is, you can write it here. There's no issue. That is, you have to show that AB is parallel to CD. I mean, ultimately this you have to prove. So construction will be actually, we will draw a line, half line EO parallel to only one side, not the two sides. Getting the point?
Yeah, ma'am.
Let me take it E. So construction will be EO is parallel to AB. So if I'll take the construction like this, parallel to CD also, right? So EO is parallel to AB, EO is parallel to CD. So ultimately AB will be parallel to CD, right?
Yeah.
So there's no point of doing the proof. So I cannot take it to be parallel to both the lines simultaneously. So construction will be EO parallel to AB only. Okay. Now you can start. So in triangle, ABC, any lower triangle you can start with. ABC, because I have drawn my line in triangle ABC. So that's why I'm taking ABC. Okay.
Okay, ma'am.
Okay. So now from here I can write. So AO upon OC is equal to BE upon EC. Is this clear? Now look in the figure carefully.
Okay.
So mark it 1. And yeah, obviously it's by BPT. Yes?
Okay, ma'am.
Okay. Now use your given condition. So, but given that, so always use words also, right? Like this, but given that, so this is given that AO upon OC is equal to BO upon DO, right? This is your second equation. Now, what can you see something similar? Yes. Left hand side is same.
Yeah.
So from first and second, you have got BE upon EC is equal to BO upon DO. Clear?
Yeah.
Okay. Now see the triangle. What is BE? What is EC? So BE is this, EC is this, right?
Okay.
And BO is this and DO is this. So that means which triangle I should take now?
CDB.
CDB. Very good. So in triangle CDB. Okay. So I'm getting these things that BE upon EC is equal to BO upon DO, right? And therefore, by converse of BPT, so my line EO, right? Only EO will be parallel to CD. So ultimately, now I have shown that my EO is parallel to CD. And now I'm going to, compare that EO is also parallel to AB by construction. And I'm getting EO parallel to CD. And therefore, ultimately, I'll get AB parallel to CD, right?
Okay.
Hmm. So you can give it some name. 3, right? Okay. So how can I write it? Now,
By construction.
yeah, I mean, just use some words. So now EO is parallel to CD, right? And EO is parallel to AB by construction, right? So comparing, so this implies that your AB will be parallel to CD. And how is this parallel?
Both of LHS equal to R.
Actually, this is by a theorem, okay? You studied in class 9th. It's not, it's not algebra that, x is equal to 2 and y is also equal to 2. So therefore, I can write x is equal to y. It's not algebra, clear?
Yeah.
It is parallel, it's not equal. So which I'm concluding that AB is parallel to CD is actually by a theorem, which let me just tell you what was the theorem. Sometimes we use it directly, but actually it's by a theorem. The theorem was that if you have, 3 parallel lines,
Okay.
3 parallel lines, for example, L, M, and N, right? So the theorem was that if your line M, for example, is parallel to L, and your line M is also parallel to N, then by theorem, your line is actually parallel to N. Getting it? So you don't have to mention the theorem, Martin. I mean, just a recall. I'm telling you that why I'm writing AB parallel to CD. Understood? And therefore, ABCD is a trapezium.
So what's the theorem name?
Name, I don't know. I mean, the theorem is, the statement is this, that if a line is parallel to two, if a line is parallel to two separate lines, something like that. I don't forget the
Okay.
exact words.
So it's a trapezium, I
Yeah,
guess.
so ABCD is a trapezium. The meaning of the theorem is this, right? If there are three lines and one line is actually parallel to the other two lines, getting it? For example, this line M is
Okay.
parallel to other two lines. So therefore, the other two lines are also parallel to each other. So that's the meaning of that theorem. I forgot the exact words what were there. So that's how you will do it, Martin. So your construction was wrong
Okay.
here. Okay. So so now your 6.2 is finished. So have we started 6.3 in the last class?
No, ma'am.
No, okay. All right. So let's come to 6.3 today.
We don't have a Pythagoras theorem, right?
Pythagoras, I think it's out of syllabus this year.
Yeah, ma'am.
6.4 and 5 are not coming in the exam. So only 6.3 you have to do. Okay. Now come to exercise 6.3. Now before starting the exercise, let's have some introduction. Just a minute, let me use my whiteboard. Yeah, it's actually easier to write here. Oh. All right. So exercise 6.3 we will do. But before that, I want to give you some introduction of the exercise. Do you remember congruency of triangle?
Yeah,
I
ma'am.
also discussed in the starting. Okay, when do we say that the two triangles are congruent? What are the
And
two
then angles
conditions?
or sides are equal.
Exactly, equal, right? And when do we say that they are similar?
When the ratio of the sides is equal,
No, sides are in the same ratio. Yeah, okay, fine. And what about angles?
and the angles are equal.
Angles are equal. Okay. So there were various criteria for congruency, if you remember, right? Which is called
Yeah.
AAA criteria, right? What is the
Yeah,
meaning of
ma'am.
that? That if in two triangles,
And
all the angles are equal, so triangles are congruent. Similarly, there was ASA, then we have SAS, right? And what else was there?
then
Anything else?
there RHS.
RHS, yes, one of the angle is a right angle, and then SSS was also there. Clear?
Yeah, ma'am.
All the sides are equal. Okay. So this was actually about congruency. So now we will also study about some criteria for similarity, right?
Okay.
Okay. So similarly, we have some criteria for similarity. So there is a criteria which is called AAA, right? And there is a criteria which is called SSS, and one more is there which is SAS. Okay, only three are there. Now what is the meaning of it? Yes, Martin, so
Yeah, ma'am.
try to understand one thing. This SSS and this SSS is different. This means that all the sides are equal, right?
Okay.
And this means they are in proportion. Ratio is
The
equal.
proportion.
Yeah, so that's something. Like for example, you have one triangle ABC, right? And then another triangle. So because they similar triangles can have different sizes, PQR. So if SSS criteria is satisfied here, so this will actually mean that AB upon PQ is equal to BC upon QR is equal to AC upon PR. So if I'm getting all the three ratios equal, so then I'll say that by SSS criteria, these two triangles are similar. Okay.
Okay.
Okay. And this SAS also, the meaning of SAS is this: if I'm getting, any one angle, for example, angle B is equal. Angle B is equal to angle Q, right? This angle is equal to this angle. Okay. Then I'll take these two sides, which are forming the angle. I'll not take the opposite side. Getting it?
Yes, ma'am.
I cannot take this side. We have to take these sides. Between these sides, the angle is there. Similarly, I'll take these two sides here. So don't write, just understand. I'll give you time to write. Okay. Yes, Martin. So if I
Yeah, ma'am.
get, so if I get AB divided by PQ is equal to BC divided by QR. So if these two conditions are satisfied, that one angle is equal and two sides are in proportion, so this criteria is called SAS criteria. Getting it?
Yes, ma'am.
Yeah. So this SAS is different from the SAS criteria of congruency. Congruency means the sides
SAS
are equal.
what?
Sorry?
What is SAS?
SAS, two sides are in proportion and one angle is equal. It means this
Okay.
SAS, right?
Yeah.
And this SAS was different. This means that the sides are actually equal in length. Okay, and here it means that the sides are in proportion. So that's the difference.
Okay, ma'am.
Hmm. Okay. Now come to this AAA criteria. For example, I have two triangles. Again, Martin, say here. Let's say I have two triangles. This angle is 60 degree. This angle is, let's say, 70 degrees. So how much is this angle?
80.
80. Fine. So if I also have 60 degree and this 70 degree. So what about this angle? How much will it come out?
80.
80 degree. So we because we know that the sum of the angle is 180 degree, right?
Yeah, ma'am.
Angle sum property, that we know that sum of all the angles of a triangle is 180 degree. So if only two angles are equal, for example, okay, ABC and PQR. So if angle B is equal to angle Q, right, which is actually equal to 60 degree,
Okay.
and angle A is equal to angle P, which is 70 degree. So if only this much is satisfied, then also AAA criteria is fulfilled, because the third angle is ultimately going to come out to be equal, isn't it? Because both are triangles. In both the triangle, the sum of the angle is 180 degree, right? So if two angles
Yeah.
are equal, the third one will obviously be equal. So it's not always necessary to show all the three angles. If you are able to show only two angles to be equal, then also the triangles are going to be similar. Okay.
Okay,
So
ma'am.
we write it AA criteria.
So only two angles need to be equal and it's proved?
Yes. So because we already know that the third one is going to be equal, right?
Yeah, ma'am.
So that's why it's not always necessary to show the third angle. Only two are sufficient. Getting the point?
Yeah, ma'am. What if
Okay.
like the third angle isn't equal?
No, it cannot happen, because the property of the triangle will not be satisfied then. In any triangle, if you can check, you can take any measurement of angles, but two angle have to be same. The third one will always come out to be same. It cannot happen, Martin, that it's not equal.
Okay, ma'am.
Yeah, because obviously the sum is 180, right? And two are equal. So ultimately the third one is going to be equal.
Yeah, ma'am.
Yes?
Yeah.
Okay. So AA criteria also sometimes we use. So only three are there: AAA, SSS, and SAS. So SAS, the point to remember is this, that the side should be the one between them, the angle is there, right?
Yeah, ma'am.
So don't take this side. You don't have to take this one. You can take this and this, because angle Q is equal to angle B. Only this you have to understand.
Okay, ma'am.
Okay, so that's it. In this exercise, only this much introduction is there. I'm not going into the proof of all this. Let's start with the exercise now.
You're writing the other. This all proof writing like AASSS.
Proof, I don't think it will come in the exam. The statement of the theorem is already written in your NCERT book. If you can just see from there, or should I write?
No, ma'am. No, I'm not talking about that. Can I write this?
Yeah, so I mean, you have understood. Yeah, that's fine.
Yeah.
Anyway, just I'm telling you the name of the theorem. So 6.3 theorem is given, right? Corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the just a minute. Yeah. Yeah, one more thing you need to understand, Martin, here. Okay, the theorem, I'm just explaining the state criteria. Will you able to remember? You have understood what is the meaning of the criteria, right? So theorem
Okay.
6.3, I just want to discuss. I'll not do the proof. So the theorem says that in any two triangles, so you have a triangle ABC, right? And then another triangle is there, DEF. Okay.
Okay, ma'am.
Corresponding angles are equal. So if angle A is equal to angle D, and angle B is equal to angle E, and angle C is equal to angle F, right? So if all the angles are equal, then their corresponding sides are in the same ratio. So basically, this is the theorem. That if this is given, yes, Martin. So by theorem, the sides will come out to be in proportion. AB upon DE will be equal to BE upon EF will be equal to AC upon DF. Yes, are you writing, Martin? Okay, you can write it down. Just, I'm not writing the statement and not proof, but just very briefly, you can write it down. Please unmute yourself, Martin, so that we can talk.
Okay.
Yeah. So just please stop writing. Just try to understand one thing. I'm telling you something important here.
Okay.
Okay, I'll give you time to write. Wait. So actually, I'm discussing about AAA criteria, which I have already told you. But from where I've got that criteria, please try to understand. So there's a theorem, from where I've got it. The theorem is this, that if all the corresponding angles are equal, then the sides will be in proportion. Because in the first exercise, Martin, I have told you about two conditions. One was about angles and one was about sides. When both of them will be satisfied, then only the triangle will be similar, isn't it? Yes,
Yeah.
both has to be satisfied, that the angles have to be equal and the sides have to be proportion. So both the conditions have to be satisfied. So only by angles I cannot say that the triangles are similar. Because this AAA criteria means from AAA, by the name it is visible that we are only talking about angles. But actually there is a theorem, Martin, that if all the angles are equal, then the sides are in proportion. So we don't write about the sides. It's obvious that they are in proportion and we call it AAA criteria. Getting the point here?
Okay.
Yes? Any confusion? Please tell me right now.
It's so like if the angles are equal, the proportion of the sides also equal.
Yes. So this is a theorem that if all the angles are equal, the sides are in proportion. So now you compare this with this. Your first condition is satisfied and your second condition is also satisfied, right? So
Okay, ma'am.
now we can say that the triangles are similar. So, and this
Oh,
similarity criterion is actually called AAA. So I'm trying to explain that AAA does not mean that only angles are equal and we are not talking about the sides. So because we know by the theorem that the sides are in proportion if angles are equal. That's the point here. Okay. Should I repeat, Martin? Tell me honestly.
So all basically A is to prove similarity, like all angles are equal and all sides are proportionally equal.
See, okay, just stop. Go back to exercise 6.1, right? So what we were doing in that exercise, for example, we have two triangles, right? It was something
Yeah.
like this exercise. Okay. So we were asked the questions like check whether these two triangles are equal or not. Oh, sorry, are similar or not similar. So what were we doing? First of all, we were checking the angles, right?
Yeah, ma'am.
PQR. So we were checking that whether angle A is equal to angle P, or whether angle B is equal to angle Q, or whether angle C is equal to angle R. So if all are coming to be equal, so one condition is satisfied for similarity. Then we were checking that whether the sides are in proportion or not. So we were checking whether AB upon PQ is equal to AC upon PR is equal to BC upon QR, right? So if this is also coming out to be equal, that means the second condition is also satisfied. And therefore we were writing that ABC triangle was similar to triangle PQR. All right.
Okay.
Yeah. So here also, Martin, just okay, let me discuss it again. There's some confusion. So like we have already discussed, Martin, that if the two triangles are similar, this means these two conditions have to be satisfied. One is about angle and one is about the sides. Clear?
Yeah.
Yeah. Now, if I talk of AAA criteria for similarity, so AAA means angle, angle, angle. So it does not mean that I'm only talking about angles, okay? Because there's a theorem which says that if all the angles are equal, for example, you have a triangle ABC and you have another triangle PQR. Clear? So there's a theorem which says that if all the angles are equal, that is, corresponding angles. I mean, angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. So the theorem actually says that if this condition is satisfied, then the sides are in proportion. I mean, always they will come out to be in proportion. So, right? So AA criteria means this. So there's a theorem involved here. So now you can compare it with your previous exercise. So you can see we are basically using two conditions here. One is about angles, the other is about side, and therefore we say that the triangles are similar. Okay.
Okay, ma'am.
Okay. Getting the point? I hope it's clear now. So AAA does not mean that we are not talking about the sides. That's it. Okay.
Okay. So which should I have to write?
You don't have to write, just see theorem 6.3 in your
Right.
book.
Okay.
In your book, see theorem 6.3. There's statement of the theorem. Can you see in your book, Martin?
Finding for it. 6, 5.
Yeah, please open your book.
Yeah,
Page
ma'am.
number, yeah, page number 131, I think. Yeah.
Yeah.
So see the theorem. If in two triangles, corresponding angles are equal, then their corresponding sides are in the same proportion and hence the two triangles are similar. Clear?
Yeah.
Why they are similar? Because the two conditions are not satisfied. Angles also, sides also.
Okay.
So this criteria is called AAA criteria. It's also written here. This criteria is referred to as AAA criteria. Right. So it's also valid for two angle, which we have discussed, which I call A criteria, right? On page number 132, on the top, you can see if two angles of one triangle are respectively equal to two angles of another triangle, then the two triangles are similar. Okay.
Okay.
So because the third one is ultimately going to be equal, that we know. Now come to theorem 6.4, Martin, in your book.
Okay.
Now, what does it say? It is actually, SSS criteria. Now, again, look at the screen, Martin. So SSS means side, 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 right?
Yeah.
So it does not mean that we are not talking about angles here. Because if you see the theorem, what is the theorem saying? That if in two triangles, sides of one triangle are proportional to the sides of other triangle, right? So here sides are proportional, then their corresponding angles are equal. So angles are going to be equal this time. And hence the two triangles are similar.
Okay.
Because sides are proportion, angles are equal, so ultimately triangles are similar. So this criteria is called SSS criteria. Okay, now come to theorem 6.5, last one. Yeah, please see in your book, Martin, 6.5. If one angle of a triangle is equal to one angle of the other triangle. Okay, please unmute
Yeah.
yourself. Yeah. Are you looking in your book, Martin?
Yeah, one
Oh,
angle of triangle is
okay. If one angle of a triangle is equal to one angle of the other triangle. Okay. And the sides, including these angles, are proportion. So as I told you, for example, if I have ABC and I have PQR.
yes.
So if angle A is equal to angle P, so I have to take these two sides to be proportional, right?
Yeah.
Okay, and the sides including these angles are proportional, then the two triangles are similar. So this is called SAS criteria. So these three criteria you have to use in the exercise. Now come to the exercise quickly. And please do the examples. Once you finish your exercise, just go back to examples and just try to solve them on your own. Okay. Now come to question number 1, Martin, here. Exercise 6.3. Okay, first part, Martin. State whether, read the question, state which pair of triangle in the given figures are similar. And write the similarity criteria used by you. And also write the pairs of similar triangle in symbolic form. Okay, there's one more thing, Martin, you have to understand here. Please see very carefully. Yes, Martin, are you there?
Yeah, ma'am.
Okay. For example, Martin, I'm using A criteria. Okay.
Okay.
Okay. Now, for example, I'm writing, just try to understand this thing. Don't write, please. Just understand here. Because once we will do questions, so you will get the opportunity to write. Now see here, if I'm writing, for example, triangle ABC is similar to triangle RPQ. Let's say this. Now, how to draw the figure? If I want to draw the figure, how will I draw?
Draw triangle and then put ABC
Okay,
and draw another triangle. Draw RPQ.
okay, ABC and then okay. So here, yeah, that's what I'm trying to explain. I cannot name it like PQR. Getting the point?
Okay.
Because if I'm writing like this means that angle A is actually equal to angle R.
Oh.
The one which is written at the first place is equal to the one which is written at the first place. So I cannot put P here. It's wrong. I have to use R here because then angle A is equal to angle
So
R corresponding. Then angle B is actually equal to angle P. So where I have B, I'll use P here. And the third one, obviously. So Q here and then C here. So this is important. Okay. if I talk of angles. Now, if I am writing this criteria, for example, SAS, right?
Yeah.
I'm again writing ABC is similar to triangle, let's say PRQ. This way I'm writing. So
So
how
R
will
will
you?
be equal to A.
Yes.
Sorry,
So
R will be equal to B, and P will be equal to A.
see, first of all, this is SAS criteria. So only one angle is equal here. Clear?
Okay.
Okay. So let me just name one triangle I can name ABC. That's okay. Now how to name the other one? Because correspondingly I have to match, right? Now ABC is equal to is similar to PRQ. Now this is SAS criteria. Now what is the criteria, Martin? So if I'm
Side angle side.
yeah,
Two
so
sides are equal.
if
One.
wait, if I'm using this angle, so these two sides I have to take. Clear?
Okay.
So here angle is basically this one. Sorry, the middle one is the angle. Getting the
Ah,
point?
okay.
So that means if angle B is actually equal to angle R. So here I have B, so I'll write R here. Understood?
Yeah, no.
Okay. Now ABC. So this is your AB side and this is your BC side. So between these two sides, there is angle B, right?
Yeah.
And angle R. So you can have like, this also means that side AB is proportion to PR. That's how we write. Okay, and this BC is proportion to RQ. So if I write the criteria, so I write AB upon PR is equal to BC upon RQ. So this has to be satisfied. I mean, I'm telling you how to name the triangles. Understood?
Yeah.
Okay, again see, if I'm writing ABC similar to triangle PRQ. Yes, Martin? So this upon this. So AB upon PR will be equal to this side upon this side. So BC
See
upon
upon
RQ.
R.
Yeah. So that's how you will write. So AB upon PR. So that means you have to write your P here. Then it will be corresponding sides, right?
Okay.
And then obviously C here. So Q here. Third one. So is it okay?
Yeah.
Okay. Now come to SSS criteria. For example, I'm using SSS criteria I want to use. And I'm writing triangle ABC is similar to triangle, let's say QRP this time. So which side is in proportion to which side? So same as I told you, AB upon QR. Clear?
Okay.
So you will write AB upon QR is equal to then this BC upon RP. So BC upon RP is equal to then the corner ones, AC, this corner one. So AC upon, I mean the remaining third side, QP. Clear?
Yeah, man. Yeah.
Okay. So how will you name it this time? Now
Mm,
you have to be careful. See here. So AB upon QR. So AB, so this has to be QR. Getting it?
yeah.
Then BC upon RP. So BC, then it has to be RP. And then AC upon QP. So that's how
Okay.
you will name it. So this you need to understand that how to write in the symbolic form. Just give me.
Okay. So do I write this?
Yes, hello Martin. Yeah, sorry.
Yeah, man.
So I hope you have understood about the criteria.
Yeah.
Okay, one question I can take very quickly. The first one, then
Okay.
rest of the parts you will try on your own.
Okay.
So look at the exercise, the first part, you have two triangles here. So this is ABC and then another triangle
Yeah.
PQR. Okay. Some angles are given. So 60° and then 80 and this is 40. Similarly here you have 80, 60 and 40. So by numbers you can see they are equal. Now you have to check whether the triangles are similar or not. And also you have to mention the similarity criteria. So what you can see in the figure, so this is how you have to write, right? So you can see that angle A is equal to angle P, is right?
Yeah.
Okay. Then you can see that angle B is equal to angle Q and
Okay.
angle C is equal to angle R. This is clear from the figure, you can see. So which criteria is this, Martin?
Ma'am, this is A.
A criteria. So by A similarity criteria, triangle ABC will be similar to triangle. So now name clearly A is equal to P. So start with P, then B is equal to Q. So Q and R this way. Yes. Now let's try one more
Yeah.
question. The second part you can see, Martin. And then there is another triangle here. This is ABC and this is PQR like that. So this is 2, 3 and 2.5. This is 6, 5 and 4. So obviously this is about sides this time. So you will check the ratio whether they are equal or not. So just carefully observing, you can see this is 2 and this is 4, right?
Okay.
Then you can compare 3 with 6. So you can check like this, AB upon QR. So this is 2 divided by 4. This is 1 by 2, right?
Yeah.
Then you can see this 3 and 6 is actually 2 times of 3. So you can check this ratio AC upon PQ. So this is 3 upon 6. So this is again 1 by 2. And then the remaining side you can check BC upon PR, right? So this is 2.5 and divided by 5. So this is all again 1 by 2. Or you can just remove the decimal, put a 10 here, then you have a 5 here. So 5 into 1, 5 into 5, and then ultimately 1 by 2. Clear?
Yeah.
Okay. Now, how will you name it? So naming is important. So which criteria, Martin, here?
It's SSS.
Yes. So by SSS criteria, now you will tell me. So triangle ABC is similar to triangle. Now how to write it?
Similar to PQR.
No, no, no. Now start from here. So this is important. Start from here. AB upon QR. So what I told you, AB will be
So
proportion to
QRP.
QR.
QRP.
Yeah. And then write the third one. So that's how. So you can take the hint from here. Understood?
Okay.
Yeah. So you are starting with AB. So you have to write QR here and then the third vertex. So give it a try, Martin, to the rest of the parts also. And you can send me the
Sure.
picture. So please complete question number 1. So only naming is important. It's only 3 criteria are there. It's very simple. But please name the triangle properly. That's important here.
Yeah. Okay.
So tomorrow, like next class, we will do from question number 2. So Martin, is there any upcoming exam or test right now?
Yeah, like 28.
28th, triangle is coming. Okay. And coordinate geometry is also coming.
Uh-huh.
Mm. Today is 18th. Okay, we have time. I think we will do it. In the next class, I'll try to finish with triangles.
Okay.
Mm. Okay, I'll give you some assignment sheets for triangles. Are you checking your portal, Martin?
Well, I'm not able to log in to it because like in
Oh, so in that
uh,
case, you have to contact Learnivio office. You must be having a number, right? Of your counselor.
maybe yeah.